whole new area of recreational maths came about because of the difference in size between British paper and American paper. And this subject is called Flexagons, and it's described in this book by Martin Gardner. Now, for those of you who don't know, Martin Gardner was an American mathematician, actually an amateur mathematician, who wrote a series of articles over many years in Scientific American magazine. And these articles, which I read when I was a teenager, kept me interested in mathematics through my school days, have been put into a series of books, of which this one here is the first. And the very first article in this book is on flexagons, and there's a picture of a flexagon on the front cover here. Now, I want to read a little passage from Martin Gardner's chapter, just to tell you how this whole subject of flexagons got started. And he says, "It all began in the fall of 1939. Arthur H. Stone, a 23-year-old graduate student from England, in residence at Princeton University on a mathematics fellowship, had just trimmed an inch from his American notebook sheets to make them fit his English binder. For amusement, he began to fold the trimmed off strips of paper in various ways. And one of the figures he made turned out to be particularly interesting. He had folded the strip diagonally at 3 places and joined the ends so that it made a hexagon. When he pinched 2 adjacent triangles together and pushed the opposite corner of the hexagon towards the center, the hexagon would open out again like a budding flower and show a completely new face." Which of course was unexpected at the time. It's kind of hard to predict something like that. And on the next page there is a picture of this very first flexagon that Arthur Stone created. Well, this interested not only Stone but several of his colleagues at Princeton, one of whom was the great, in fact, world-renowned 20th century physicist Richard Feynman. And Feynman and the others who were friendly with Stone at the time began to look more into these flexagons and kind of explore the mathematics behind them. What I'm going to do next is have Agnejo come up and show you a couple of flexagons that he's made and demonstrate exactly how they work.
This is the first flexagon discovered by Arthur Stone. You can see that it's got green on one side and blue on the other. But one of the important things that Arthur Stone discovered was that there is a third face. And indeed, if you pinch these together, it then opens up, revealing the red face, which originally wasn't visible. That's because it's actually inside the flexagon. So fold it and open it again, and that reveals the blue face. And so on. You can cycle between these 3 faces. And this is the most basic type of flexagon. It's probably the easiest one to make, and so it's one that many people will be familiar with. But there are other types, and not all flexagons are hexagonal. Here's an interesting puzzle. This tube has dark blue on the outside and red on the inside. Can you turn this inside out without tearing the paper? Of course, many people would try brute force, like trying to twist this inside out, but unfortunately this will pretty much invariably tear the paper. So brute force is not the correct method. In which case, what is? Well, this is actually a flexagon, so what you can do is fold it into a domino shape, then open it up to reveal the yellow face, at which point you can then fold it and flex it again to reveal the red face, and then this can be folded again into a domino shape and open up into a tube, this time with red on the outside and dark blue on the inside. So this is an example of a square flexagon. It's known as a tetraflexagon because it has 4 sides, and it's again quite simple to make, and quite common. It's actually got some practical use. This mechanism has been used, for example, in certain hinges. So these flexagons do occasionally find use. They're not always entirely recreational.
So I hope we've shown that you don't have to be a mathematician to enjoy some interesting areas of maths. All you need is some card or paper, scissors and some glue, and you can make your own flexagons and explore them to your heart's content. So until next time, happy flexagoning.